In the previous videos, we discussed about relations, correct? Now let's discuss about functions. So functions are a major part of math because everything, whatever you see, any sort of an algebraic expression or any sort of a trigonometric expression, they are all part of functions. Alright? Now, whenever we talk about a function, how do we represent a function and what is a function? It's a very important thing. Okay, now the formal definition of a function is, suppose say you have two sets. Okay, we'll look into the visual representation. Suppose say you have two sets, one set here, say we have one more set here. So assume that you have two sets. So these two sets, let's call it as A, let's call it as B. Now there are two elements within this. Say we have A and say you have B. Okay, you have A and B. Now there is a relation between A and B. Okay, now since there is a relation, what we say is that a function f defined between A and B such that there exists a relation between A and B, and also a very important thing is, for every image in B there is only one element in A. In the sense here A is related to B, correct? So there is a relation like this. We define the relation as a function f. Okay, we define a relation as f. That means here f is a function which goes from A to B. In other words, f is the way of defining a relation. Because in the previous videos you saw different types of problems with different conditions given, if you remember, right? So basically those conditions which define a relation, that is basically a function. So what we tell and how we write it is f is a function from A to B. Here A is the domain and then B is the range, or you can say B is also the codomain. But there is a very, very important condition between A and B which differentiates between function and a relation. Okay, now in a function, what you have is, for every image there has to be a pre-image. Okay, for every image there has to be a pre-image. Pre-image is what? Pre-image is an element in the domain. Okay, image, you guys know what it is. Pre-image is nothing but the element in the domain. So this is how we define a function f. Okay, so for every function f which goes from domain to range, we have f from A to B, what you are seeing. Fair enough? Now, whenever we talk about function, of course there are certain general properties of functions, like what we call as the algebraic properties of functions. Okay, like addition, subtraction, all those things. We'll look into these properties now. See, we have to understand the properties, correct? Very simple. More than properties, you would say the algebraic operations on functions. Okay, so the first one is the addition function. Very simple. Suppose say there are two functions, f from some value A to B, and say we have g which is also from A to B. Fair enough? Say we are going to add the two functions. That means we'll do f plus g. Now what this additive property or the addition property tells you is that when we add two functions, we can write this as f plus g is also from A to B. F plus g is also from A to B. So this is basically addition of two functions. Alright. So we'll look into different examples. We'll solve few problems. Then you guys will understand how this addition works. Fair enough? The second one is the subtraction. Whenever we talk about subtraction, it's the same logic. Suppose when you have f from a to b is one function, g from a to b is another function. Then subtraction is f minus g from a to b. This becomes subtraction of two functions. And one more thing I want to be very clear with you guys is that whenever we talk about these functions, we talk about real functions. In the sense, the domain and the codomain, both of them are real numbers. We are not looking at any other type of numbers here. We are looking just real numbers. Clear? So that's why whenever we write f minus g, f plus g and all these things, the domain and the range both are real numbers. Fair enough? Now, we'll start with the next part, which is the multiplication. For multiplication, there are two things. Okay, so first one under multiplication. So you have multiplication. The first case under multiplication is multiplying by a scalar. In the sense, we take a number, a constant, and we multiply to a function. That means, suppose say f is a function from a to b, and let's say alpha is a constant, alpha is a scalar or a constant, scalar or a constant. Then what we can say is that alpha into f, alpha into f, this also is from a to b, and alpha into f is what we call as multiplying the function by a scalar. Guys, I'll give you a simple example. Suppose say you have x square plus 2x plus 1. Okay, and can multiply this equation by 3. That is 3x square plus 6x plus 3, which is nothing but 3 into x square plus 2x plus 1, which is nothing but alpha into f or alpha into f of x. Okay, so this is one type of multiplication. Now we have another type of multiplication. In the another type of multiplication, suppose what if you multiply two functions itself? Like what if you multiply x square into y, x square into y, or x square into yx, it will become x cube into y, correct? But here we are multiplying two different functions, isn't it? So here, suppose say you have f is a function from a to b, g is a function from a to b. Then we multiply these two together. That means you will have f into g, which goes from a to b. Now one thing I want you to understand is that this type of multiplication is called as pointwise multiplication. It's called as pointwise multiplication. Fair enough? Remember, in multiplication only two. One is with a scalar, one is with a constant, another one with two different functions. That's what we call as the pointwise multiplication. Okay, now let's do for the last part, which is the quotient, the division between the two functions. Now in division, the last one, you can say division, or you can also call it as quotient. See, whenever we talk about division or quotient, we are doing f is from a to b, g is also from a to b. Now what we are doing, the quotient is going to be f by g is also from a to b, provided g is not equal to 0. Because if g becomes 0, then it makes no sense, correct? That's why g should not be equal to 0. Okay, now to summarize, what are the four basic properties or four basic algebraic properties or algebraic operations on functions? First one, what we have is addition. So for addition, we are going to have f of x plus g of x. Remember, we did f from a to b, it's nothing but f of x. f of x plus g of x is nothing but f plus g of x. You can just add the first one. So this is the first one. Second one is f of x minus g of x is f minus g of x. Got it? Next, in the third one, there are two parts, isn't it? So the first part is going to give us alpha into f of x is nothing but alpha into f of x. First case. The second case is what? Suppose if you have f of x into g of x. This gives us f into g of x. Correct? And the last one, fourth one is if you have f of x divided by g of x, this will become f divided by g of x, provided g of x or g, let's be more specific here, g of x is not equal to 0. So these are the four basic arithmetic or algebraic operations on functions. Correct? Now remember one point, very extremely important point in function is for every image there has to be a pre-image. That means for every element in the image there has to be one element in the domain. This is what we call as a function. So in the next video you will see different examples of functions, most common ones, type of functions. You will see those things in the next video.